Hello and welcome. In this video, we are going to solve problem number 23 of linked list, that is merge k sorted list. So in this problem, we have given an array of k linked list which is already sorted, and we have to make a merge linked list using this k linked list, and we have to make sure that our resultant linked list should also be sorted. So you can see that we have drawn these three linked lists. So this is first one is 145, second is 134, and 2 6. You can see that all of three are sorted. So if you are making a linked list out of this, then first will be at the first place, then second at second place there will be one, and at third place there will be two, and then three, four, five. Four will be at two time, this four and this, and then five and six. So this is going to our merge linked list. So how we can solve this? We have already seen a problem where we have merged two sorted linked list. So in this problem, value of 2 is replaced with the value of k. So we can have any number of linked list, and we have to merge them and return the resultant linked list. So as we already discussed in that video, if you not watched that video, please go and watch that. That is going to be prerequisite for this video. Okay, so we are going to use that approach very much in this video also. So let's come back to this video, and okay, so how we can do this? We are going to use a data structure. This in naive approach, this is going to be our naive approach, or we can brute force approach. We use a data structure and store all the result. Then in second step, we sort the data structure, and in third space, make linked list out of all values that we already stored in data structure. Okay, so how much time does it going to take? So for storing all the data structure, let's n be the total number of nodes. So for that, it will be going to take big O of n time. Okay, and for the second, we have to take big O of n log n for sorting, and at last, to make a list out of these values, we have to take big O of n time. So again, this is going to take big O of n, big O of n log n plus big O of n. Okay, so this is the time complexity that we are going to follow in this case, and obviously there will be space complexity of big O of n. So can we improve this complexity? Yes, we can. So how we can do that? We can do a two pointer method that we had used in previous video. We will be using a two pointer, and we will be comparing one and one, and then we'll after that we will be first merging these two. Then this is going to be 1 1 3 4 4 and 5. So this is going to be our new list, and then we have to do same for this. We'll be using two pointer in this both, and after that we'll be merging this is going to be 1 1 2 3 4 4 and 5 6. Okay, what is our result? Okay, so this is the one way that we can follow. And what is the time complexity for this? So this is going to take, okay, so in this case, like we can have linked list 1, linked list 2, linked list 3, linked list 4, linked list 5, linked list 6, and so on. Okay, so what we'll be doing, we will be making a linked list out of this linked list 1 and linked list 2. This is going to be, let's say, linked list 1, and then we will be making a linked list out of this linked list 1 and linked list 3. Again, let's say this is going to be linked list 1. Again, we will be making linked list out of this linked list 1 and linked list 4. Again, we will be storing somewhere, let's say it is linked list 1, or our result. So let's say no, it is our result. Okay, so then result. Okay, so again, for we'll be doing result and linked list 4. We'll be using, we'll be merging these two. After that, it will be going to return a result. Again, we will be merging these two and going to return. So how much time does it going to take? So let's say there is a total k linked list, so it is going to take k into n time. Okay, so we have to do k time all the merging, and any total number of nodes. So this is going to take big of k n. Okay, so though it is a optimized approach, better than previous one, but this is not the most optimized. So how we can solve this problem using most optimized approach? So let's say we have again linked list 1, linked list 2, linked list 3, linked list 4, linked list 5, linked list 6, and let's say on for now only linked list 6, linked list 7, linked list 8. So for now we have 8 total linked list. So we'll be using merge sort approach, that is divide and conquer method, divide and conquer method. So that, let's see what does it. So we'll be first merging these two. This is going to return a linked list. We will be storing somewhere, let's say linked list 1. Then we'll be merging this linked list 2. It is going to take, this will be resulting a linked list. This is going to linked list 3. Again we will be merging these two. This is going to return a result. This is going to be linked list 5. Okay, then we will be merging these two. This is going to return a result which is going to linked list 7. Now we will be merging this resultant. Okay, so after merging this, this is going to return result which is going to linked list 1. Then we will be merging these two. This is going to return linked list, and this is going to linked list 5. Okay, now we'll be merging these two result, and we'll be merging this, and then after that we'll be having linked list 1. So this is going to our result. Okay, so how much time does it take? So every time we are reducing our a step by k by 2 time. Okay, so this is going to take big O of log k time. Okay, and any total number of nodes. So this is going to take big O of n log k, which is much better than the previous one, and this is the most optimized approach that we can come up with this for this problem. Okay, so what we are doing, we are first merging these two, then we'll get a result. Again same will be followed for all the, and then we'll be merging these two. So this is the approach that we are going to use. This is the same approach that we use in merge sort. So the code for this problem is going to similar like that. So we'll be using a helper function for that, where we'll be calling, or we'll be sending our all the lists, and start index and end index. Okay, so then we'll be, if we'll found that our start is equal to end, this is the base case they have to follow, then in this case we will be return list of a start. Okay, and then after that we have to write the code similar like that we write in merge sort. So first we have to find the mid, and then this is going to be a start plus end divided by 2. Okay, now let's say this is the total number of linked list. We are for linked list here and for linked list here. Okay, so we are dividing this into between, and now we'll be solving this part and this part. Again for this part we'll be dividing this, and again for this part we'll be dividing. Same will be followed until unless we will found a single linked list, and then we'll be merging the resultant. Okay, so now after that we have to call a list. Left part will be called, left will be stored in a data variable that is going to be left. This is list node. Okay, and then in this we will be calling this helper function. So this is going to call helper with list, and for this the starting point is going to be the start that we have already sent a start, and the ending point is going to be this mid. Okay, so this is our mid. Okay, and then we'll be calling for right part. For right part, starting is going to be mid plus 1, and end is going to be end. So we'll be calling helper lists mid plus 1 and end. Okay, after that we have to merge these two. Once we'll get left and right as single, and then we'll be merging this and we'll be returning. Then for that we'll be calling merge to lists function. Okay, that we had already implemented in one of my previous video. You can check that out if you want to get better understanding in this. Okay, so we'll be merging this using this function list 1, sorry, not list 1, left and right here. Left and right will be sent here, and we will be calling this, and at, we have to also return this. Okay, so this is the function, and that we have to write and follow the code. So let's go to the compiler and write the code for same. So first we have to call the helper function. So for that we'll be finding the length is going to be n equal to, sorry, here we can take k. Okay, list dot length. Okay, and then if we found that our k is equal to 0, then we don't have to do anything, just return the null. Okay, and then we will be calling merge the helper function, whose name is, we are going to take merge k lists also. Okay, so there will be sending our lists, a starting index that is 0, last index that is k minus 1. Now it's time to create this helper function that we are talking about. So for that we will be using private list node merge k list node will be received here that we are sending from the list node and list int start index and int end index. If we'll found out that our start is equal to our end, then in this case we will be returning lists of a start. Okay, so now we will be finding the mid is going to be a start plus end minus a start divided by 2. Okay, now we will be finding the left part. This is going to list node left equal to merge k list node. A start is going to be beginning and for end it is going to be mid. Okay, same for right. A start is going to be mid plus 1 for this, and end is going to be end. Okay, at last we will be returning result which is merge two lists, and in this we have to send left and right. Okay, now it's time to create this function that we have called at last, that is private list node merge two lists. Okay, here we will be sending this list node list 1 and list node list 2. Okay, so first we have to check in this. We will be creating a result list node that is dummy node, and we have to store it somewhere, so we'll be using a list node for same temp equal to result. Okay, now we have to run the while loop inside this, and we have to make sure that we are iterating only when our list 1 is not equal to null, and at the same time list 2 is not equal to null. Now if you find out that list 1 dot value is lesser than equal to list 2 dot value, in this case we'll be doing some work inside this, and in else parts we'll be doing some work. So in if the first condition is satisfied, then we have to append the list 1 in our resultant and then move the list 1 by one step forward. So we'll be doing temp dot next equal to list 1 and then move the list 1 by one step. List 1 is going to list 1 dot next. Same will be followed for second, so temp dot next equal to list 2 dot on list 2 and move the list 2 one step forward. And in every space we have to move our temp by one step, so for that we'll be doing temp equal to temp dot next. Okay, and then if we will check whether any node has been left or not, so we'll found that list 1 is not equal to null. In this case what we will be doing, we will be doing temp dot next. We have to append that in our result, so temp dot next is going to our list 1, and same will be for list 2. Temp dot next is going to our list 2, and then at last we have to return our results, which is going to result dot next. Okay, now it's time to run the code. So yeah, merge k list, there is error. Yeah, now run again. So there is okay, so we send this lists. We have to send lists. My bad. Run again. Yeah, so we have passed the first test case. Let's check remaining two. So we have passed all the given three test cases. It's time to submit our solution and check whether our solution has been accepted or not. So our solution has been accepted, and this is faster than 98.36% of Java submission. In that case, if you learned something from this video, please make sure to like the video, subscribe to the channel, and don't forget to share this video among your friends. Thank you.